Hi everybody, it's me, Mr. Marshall, your physics teacher. I am going to be having you guys work in the library today on a PhET simulator on forces. The way you get to the simulator is just going to PHET, forces in 1D, one dimension, and it's pretty much the first link. On the worksheet, I also did give you the full explanation on how to get to the full link to the website. When you run it, it might give you some options on either running it, saving it as, or whatever. The computers in library might be a little different. Don't bother updating Java or anything like that. See if you can open it. Yeah, I'm not going to update. I know it's recommended. Do it later. You probably don't have permissions to anyway. The worksheet you got is going to ask you first for your quick definitions of Newton's first, second, and third law. Should have these in your notes. And then you're going to go to, again, it gives you play with sims, run now. This will open you right up into this simulation. So the first thing you're going to do is to start to look at the forces that it takes to resist motion. So the first question is, without movement, what's happening to these forces? So you want to look and you'll see something like that they're balanced, and that's an important piece. Multiple forces can be balanced, multiple forces can be unbalanced. Net force, or what they're calling total force, is the amount of force that's winning. When I stop pushing, now all of a sudden you have friction. That's the only force acting on it, slowing it down, making it accelerate in the negative direction. When it's not moving, there's no opposition to motion, so the filing cabinet, there's no friction showing up. So there are a couple experiments, there are a couple tabs so that you can see the graphed forces, the graphed acceleration, and the graphed velocity. So you're going to be drawing some of these graphs for each one of your scenarios as you go. And on the back, you're going to do a little bit of work. You can turn friction on and off up in this left-hand corner here. Friction off. So now if you push the cabinet, give it a little shove, again, force is mass times acceleration. It does have a pretty good mass, so it didn't really accelerate that much. I can also change to sleeping dog. If you give the sleeping dog a good shove, he is going to have a good deal more acceleration, more velocity going across. So what you're going to do is first use the simulator to first you're going to answer some of these questions on the back with your math, then you're going to use the simulator to answer them, and then there's a handful of conclusion questions for you to work on. So you'll be in the library for it. There's free body diagrams that are going to show up in the upper right hand corner up here that I think you can expand, make bigger. Again, so free body diagrams to help you reflect on what those are, work out your force, mass, accelerations, get that math done correctly, do the conclusion questions, and that'll all be done in the library today in class. All right. Thank you, everybody. Have a good day.